Welcome to this video on Computer Networks Why. We will explore the fundamental concepts, advantages, and components that make up these essential systems. In this introduction, we will define what a computer network is and how it functions as a foundation for modern communication. A computer network is a set of computers connected to share resources. The most common shared resource is the internet, but it can also include printers or file servers. Next, we will examine the various advantages of implementing a computer network in a professional or personal environment. Key advantages include enhanced communication and information availability, more convenient resource sharing, and simplified file sharing between users. Furthermore, networks offer high flexibility, provide an inexpensive communication system, and help boost overall storage capacity. However, it is also important to consider the potential disadvantages associated with networked systems. Disadvantages include a lack of independence, increased security difficulties, and a lack of robustness if components fail. Other concerns involve the risk of computer viruses and malware, the requirement for efficient technical handlers, and the potential for expensive setup costs. To understand how these networks work, let's look at the primary components involved. The core components of a computer network include hubs, servers, clients, and the communication channels that link them together. First, we look at hubs. Hubs are essential hardware devices used to connect multiple devices in a network segment. A network host is a device connected to the network that offers resources or services. Hubs generally fall into two categories: active and passive. An active hub electrically amplifies the signal as it travels between devices, essentially acting like a repeater to extend network reach. Repeaters are specifically designed devices that receive a signal, electrically amplify it, and then rebroadcast the signal across the network. Moving on to passive hubs, these devices act as a simple connection point. They allow signals to pass from one computer to another without changing or amplifying. Next, let's discuss servers, which are a vital component in any computer network architecture. A server is a computer or device on a network designed to manage network resources. These are often dedicated to specific tasks to ensure network efficiency. Following the server, we have the client component of the network. A client is a piece of hardware or software that accesses services provided by the server. This interaction is key to how networked resources are consumed. Now we will look at the communication channel, the medium that allows for data transmission between network components. A communication channel, or simply a channel, refers to a physical transmission medium like a wire or a logical connection over a multiplexed medium. Communication channels are generally categorized into two main types: wired or guided channels and wireless or unguided channels. Let's first explore the wired or guided communication channel. Guided media involves physical connections like network cables. Common examples include twisted pair cables, coaxial cables, and fiber optic cables. Alternatively, we have the wireless or unguided communication channel. Unguided media facilitates connections through air or space, such as radio waves, microwaves, and satellite transmissions. With the components understood, let's look at the different types of computer networks. A network can range from a small group of linked computers to a massive chain of hundreds of different devices spread across the globe. Networks are primarily classified based on their geographical spread, most notably into local area networks or LANs, and wide area networks or WANs. We will now categorize networks based on their geographical reach, starting with the local area network, or LAN. A LAN is a small computer network confined to a localized area, such as an office, building, or factory. Its primary purpose is resource sharing, allowing users to efficiently share data, information, programs, and hardware like printers or modems. Next, let's look at the wide area network, commonly referred to as a WAN. WANs span across large geographical areas or multiple countries. They connect computers separated by significant distances and can effectively link multiple LANs together to function as one large network, often utilizing public systems like telephone lines. This diagram illustrates the architectural distinction between the centralized nature of local area networks and the expansive, interconnected structure of wide area networks. Understanding the differences between LANs and WANs is essential for network design and implementation. While LANs typically offer high speed over shorter distances, WANs are designed to bridge vast geographical gaps, which often impacts speed and infrastructure complexity. Beyond geography, we can also classify networks by the roles and components they use. Networks can be classified by the role computers play in operations, leading to two main types: peer-to-peer networks and client-server networks. Let's first explore peer-to-peer, or P2P, Networks. In a P2P network, all computers are considered equal, and each can function as both a client and a server. Computers in a P2P network that share resources are often referred to as non-dedicated servers because they are not exclusively reserved for server tasks. P2P networks are popular in homes and small businesses due to their low cost and ease of installation, though they do face limitations regarding security and scalability. Now let's examine the alternative architecture, the client-server network. Unlike P2P, a client-server network features dedicated computers that act as servers, providing specific services or resources to client workstations, creating a more centralized management model.